Okay, so we are back to solving more trig equations for the second part, but there is something distinctly different about these trig equations. So the first thing I'm going to talk about is what makes that clear from the trig equation we've just solved. So this is between 0 and 360, so we're working in degrees, so nothing different there. The key difference lies in the fact that we've got sines and coses in the same equation. That's clue number one, that something's a bit different. Clue number two is that we have one of them has x's as their angle, the other one has two x's. So this is not like last week where we were able to solve it and then divide everything by 2 at the end. We need to deal with this 2x and get rid of it first because we can't have both 2x's and x's in the same equation. The big clue is that anytime you see an equation like this, which has sines and coses in it, or has angles which are not matching, so 2x's and x's is a common one that you'll see. Anytime you see that, you are required to use some kind of identity from back in December. So the things we learned back in December for trig identities are now coming in really handy with solving this type of trig equation. The good news is, if you get a question like this in a higher paper, the chances are that they will give you a two-step question. Part A will be to change this into a trig equation that you know how to solve, and part B will then go on to solve it. We're going to look at today solving them straight through from the start, partly because you know that all the questions you're going to see in this task are of that kind. So what we're going to do, well, the first thing we need to do is change our sine 2x to something different. The only thing that you know how to change it to is the identities that we looked at in class. Remember, they are in the formula booklet for you as well. So you can look up sine 2x is the same as 2 sine x cos x. So let's change that to the only other thing we know what it is, could be. There it is. This bit doesn't change, and we still equal 0. Now we can expand out, so we get 8 sine x cos x. And we've got plus 3 cos x over here. And still equals 0. This is looking a bit more like the kind of thing we've been solving in task 1. There's not a quadratic involved here, but we do have a cos x in this bit and a cos x in this bit, so we can still factorize. So let's put that cos x out the front. That leaves us with 8 sine x from the first term plus a 3. So all I've done is I've seen there's a cos x there and a cos x there, so that's gone out the front. Well, taking a cos x out of this term leaves us with the 8 sine x. Taking a cos x out of this term leaves us with a 3. Okay, now this is again very like the lesson that we've just done with the quadratics. We've got two things that could happen here, two things multiplied to make 0. So either our cos x equals 0 or our 8 sine x plus 3 equals 0. Those are our two possible options. I'm just going to split down the middle of my page while we deal with each of those options. The cos x equals 0 option is the one where it's probably easier to draw a graph than it is to try and use any other fancy method. Center is 180, so that makes that 90, that's 270, that's 360. So my two places where the cos graph is 0 is at 90 and 270. So we've got our solutions there, x equals 90 degrees, or it equals 270 degrees. And like I've been doing in the worked solutions and in my examples in task 1, just highlighting these as we go through so we don't lose any answers. At the end, we've remembered all our different answers that we've calculated. On the other side, we've got 8 sine x plus 3 equals 0. Let's solve that. So we end up with 8 sine x equals minus 3. So sine x equals minus 3/8. Now, because it's a negative equation here, we're going to have to think, we're going to have to use slightly different methods if we do our cast or we do our graph. So for the graph, we're doing sine to the minus 1 of minus 3/8. If you're doing cast, you'll want your relative acute angle, which is sine to the minus 1 of positive 3/8. well, they're quite closely related. This one over here is minus 22.024312. This one over here is just positive 22.024312. On our graph, so our negative angle is along here, and our two positive ones appear along here, and hopefully you're spotting on our graph that bit, and that bit are all fairly similar. Well, this is 180, so our first angle there is 180 plus 22.024312, and our second angle there, well, this is 360, so we're doing 360 minus 22.024312. From our cast, we get exactly the same result. There's our little cast diagram. Sine is negative here and here. Well, if that's 180, then this bit here is 180 plus our relative acute angle. This is 360. So this is 360 minus our relative acute angle. Let's work those out. What do we get? Well, our first one gives us 202.02431, which is approximately 202.02. The second one here, you get 337.975687, which rounds to 337.98 degrees. Those are possible answers. Both of those are in the range that we're interested in, so we highlight them. And now we just list our answers at the end here. So our answers are either 90 degrees, 270 degrees, 202.02 degrees, or 337.98 degrees. And that's our finished answer. Now, you can have a go and see how you get on. There we go. So the one I want you to have a try with is that. If you pause the video, I will run through the answer in just a moment on the video. Excellent. So hopefully you paused, you've had a go. Again, first thing we want to do is replace the sine 2x. We can replace it with 2 sine x cos x. Next thing we want to do is expand and simplify that. So there I'm doing that. And then I've got this equation and I factorize out a cos x, just like I did in the last one. So factorizing out a cos x. That gave us two possibilities, either that the 2 cos x bit equals 0, or the 7 sin x minus 1 bit equals 0. If you left the 2 inside here, so you left it as 14 sin x minus 2, and you only put the cos x outside, nothing will go wrong. You'll get exactly the same answer at the end. It'll just look a little different in the middle here. Solving each of those, if we solve 2 cos x equals 0, it's exactly the same as what we had, same graph we had a minute ago. So our answers are 90 and 270. And the 7 sin x minus 1 bit, add the 1 to both sides, invert the sign. Our relative acute angle is the same as our x here because we're working with a positive number. That gave us 8.21. We can use our graph for our cast to find the other answer. So there at the bottom are our 4 possible answers. We either have 90, 270, 8.21, or 171.79. So hopefully you've managed to work your way through that and get an answer which matches what I've got. So in this part, we've looked at what to do with a sine 2x appearing in our equation. The next video is going to look at some of the other trig identities we might end up having to use.